Good morning. Welcome to e-learning. I am P. Saktivel, Assistant Professor, Department of EEE, Thandai Periyar Government Institute of Technology, Vellore. Today's topic: Power Electronic Switching Devices. What is power electronics? Power electronics is a subject that deals with the apparatus and equipments working on the principle of electronics, but rated at power level rather than signal level. Whatever be the devices you are studied in your lower semester, such as diode, BJT, MOSFET, IGBT and SCR, that are signal level devices. Next, we study what is the principle of electronics. The principle of electronics is the current flow is due to movement of holes and electrons. Next, we compare the signal devices and power devices in terms of the ratings. In case of the signal devices, it can handle the power in milliwatts. That is, it can handle maximum of 24 volt and current in terms of milliamps or microns. But our power devices can handle the power in terms of kilowatts or megawatts. In order to handle the power in terms of kilowatts or megawatts, it have the capability to handle the voltages in kilovolt and currents in terms of kiloamps. Applications of power electronics. First application, aerospace. In aerospace, it is used to give the power supply to the aerospace. Next, commercial applications, AC, heater, UPS and elevators. It also finds its applications in industry. In industry, it is used in welding, transformer tap changing, arc furnace. It finds its applications in residential buildings, also in AC, cooking, lighting, computers and light dimmers. Telecommunication application is battery chargers. It is also used in transportation such as electric vehicles to control the voltage. It finds its too many applications in utility systems such as HVDC transmission, static circuit breakers and excitation, etc. Advantages of power electronics. It provides high efficiency due to low losses in devices. Second one, it is highly reliable. Third one, long life and less maintenance because absence of moving parts. Fast response, low cost due to mass production. Due to mass production, the size and weight also reduced. Disadvantages of this power electronic devices. Generally, the power electronic devices are connected in between the supply and load. So, during the operation of the power electronic devices, it generates harmonics. So, this generated harmonics will be supplied to both supply system as well as the load system. This generated harmonic will distort the voltage waveform. Generally, the power electronic devices provides only low input power factor. It can have low overload capacity and regeneration of power is difficult. Switching devices. A switching device is any mechanical, electrical, pneumatic or hydraulic device designed to open or close an electric circuit. So, in short, it is used to open or close any electric circuit. That device is known as switching device. There are three switching devices in power electronics. First one, diode. Example, power diode. Second one, transistor. Examples for transistors are BJT, MOSFET and IGBT. Third one is thyristor. Examples are SCR, LA-SCR, RCT, GTO and triac. First we go with power diode. This is the diagram of the power diode. It is the symbol for the power diode. It is a two terminal devices. Name of the terminals are anode and cathode. Next one, power transistor. The first power transistor is BJT, abbreviated as bipolar junction transistor. It is a symbol for the BJT. It is a three terminal device. Name of the three terminals are base, emitter and collector. Next one, MOSFET, abbreviated as metal oxide semiconductor field effect transistor. Similar to the BJT, it is also a three terminal devices. Name of the three terminals are gate, drain and source. See here, there is an arrow both in BJT and in MOSFET. The direction of arrow indicates the direction of flow of current. Next power transistor is IGBT and abbreviated as insulated gate bipolar transistor. It is also a three terminal devices. The name of the three terminals are gate, emitter and collector. IGBT is the combination of BJT and MOSFET. And next power transistor is SIT, static induction transistor. The name of the three terminals of SIT are gate, source and drain. Next, power thyristors. The first device is SCR, abbreviated as silicon controlled rectifier. It is a symbol for SCR. It has three terminals, namely anode, cathode and third terminal named as gate. Generally, gate is a control terminal. Next one, LASCR, that is light activated SCR. Very similar to the SCR, it has anode, cathode and gate, but its conduction is activated due to the application of the light rays. So it is named as light activated SCR. Next one, triac. Here the terminals are not fixed as anode and cathode because it is a bidirectional device. In either direction current can flow, that is from left to right the current can flow, or the current can flow from right to left. So the name of the terminals are main terminal 1 and main terminal 2 and the control terminal is gate. Next one, GTO, gate turn off thyristor. Its off process can be controlled by the gate pulse, so it is named as gate turn off thyristor. It has also three terminals, anode, cathode and gate. Next, types based on control. Based on the control, the power electronic devices can be classified into uncontrolled turn on and uncontrolled turn off device. Example, power diode. Next one, controlled turn on, uncontrolled turn off. In this case, the turn on can be controlled but turn off cannot be controlled. Example is thyristor. In the third case, controlled turn on and off. Both turn on process and turn off process can be controlled. Example, BJT, MOSFET, GTO, IGBT and SIT. Next one, voltage controlled device. Examples, FET, MOSFET, IGBT. That is, its control process can be controlled by the application of the voltage signal. If the control process is carried out by the current signal, that is known as current controlled device. Examples are BJT and SCR. Next, types based on current capability. Whether it can conduct the current in unidirection or bidirection. Bidirection means both the directions, from left to right or right to left. Only two devices are bidirectional devices, triac and RCT. RCT means reverse conducting thyristor. All other remaining devices are unidirectional devices. Examples for unidirectional devices are BJT, MOSFET, IGBT, SCR and GTO. Types based on voltage withstanding capability. Based on the voltage withstanding capability, power devices are classified into two. One is unipolar devices, that is BJT, MOSFET and IGBT. Second one is bipolar devices. Examples are SCR and GTO. Thank you.